Okay, this is Héctor Viguer. I'm the CEO of Brainstorm Multimedia, and I want to introduce Thomas True, senior engineer at NVIDIA. Hi, Thomas.
Hello. Good afternoon. Yeah, so as Hector says, I'm the senior applied engineer at NVIDIA. Happy to be here this afternoon on the Brainstorm virtual set to talk about how NVIDIA RTX GPU technology is used in InfinitySet and how over the years we've worked with Brainstorm. We have a great partnership both on the engineering and the marketing side to push the GPU technology into InfinitySet and also feedback and bring new features to the GPU that they can use in the future.
Please make a presentation about how your RTX or your system is making Brainstorm InfinitySet technology evolve, and what are the features, please.
Yes. Yeah, so believe it or not, it's been 20 years that we at NVIDIA have been putting our GPUs in broadcast and making great visual effects in movies and entertainment and virtual sets. And traditionally it's been all about the graphics and the great rendering capabilities, but now it's also about AI features that we're adding into the GPUs. And these GPUs, they can be in the workstation, or they can be in the cloud, or they can be in the data center. Yeah, so just a little bit about the evolution. The current evolution of GPU is the Ada architecture, and every time we add a GPU, we kind of like double the performance as we go through. We can talk about some of the features of the current Ada GPU. So basically there's four legs to the stool. There's the streaming multiprocessor, which are the cores that do the rendering. There's the video codec capabilities. There's the new tensor cores for AI, which I'll talk about a little bit more. And then there's the ray tracing aspect for ray tracing and really accurate, high precision lighting. So let's talk about each of these. Yeah, so let's start with the encoding and video decoding. So if you have a virtual set and you want to bring video into your virtual set, then you would use the decoders on the GPU to bring video in, and then if you want to send your program feed out to do some encoding of the program feed, then you have the encoder to do that. And with the Ada architecture, we have 3 times the performance of the encoders, so you can encode or decode 3 times the streams now with the best quality. And we've also added in the Ada GPUs the ability to do AV1 decoding and encoding, which is higher quality at lower bit rate. And then finally, new in Ada is the ability to do 8K encoding and decoding by ganging together 2 of the encoder decode engines, and at the same time you can use the third one to do encode or decode something else. Talking about the tensor cores. So tensor cores, those are the cores that do the matrix multiply and accumulate that you would use to do AI training and inference. So the Ada GPUs, we have up to 2.4x performance of the previous generations for doing training. And what do these tensor cores bring to broadcast and virtual production? They bring real-time player tracking, talent tracking, real-time telestration. They can do transcoding of one language to another language. They can do voice-to-speech, speech-to-voice, all those kind of features. Those are all thanks to the tensor cores on the GPU. Moving on to the RT cores. So the RT cores, those are the ray tracing cores on the GPU that accelerate. When you do ray tracing, you shoot light rays into the scene, they intersect triangles, and that's how you compute the color and the lighting of that pixel on the screen. So the ray tracing cores accelerate this process. And what's new in Ada is, before the Ada generation GPUs, we couldn't really do ray tracing at 60 FPS like you would need for a virtual set like this. But with Ada, now we can do 60 FPS ray tracing and bring ray tracing into virtual production and live media. And that's like a game changer in this. And then in addition to the ray tracing helps you with the rendering of high scenes with really complicated lighting. Instruction shader execution reordering. So when you're doing this ray tracing, you're using geometry shaders, fragment shaders, and compute shaders, and the shader extractions become really chaotic and complicated, and we have shader execution ordering to make them be rendered on the GPU much faster.
Yeah.
And in virtual production, in virtual set, it's all about frame time, right? Are we 60 milliseconds per frame or 20 milliseconds per frame? How high can we render the geometry in high quality in that frame time? So if we can reorder the rendering instructions on the GPU to execute them as efficiently as possible, then folks like Brainstorm can render higher complex geometry and bring more great content to the viewer. Moving on, DLSS3 is another big feature of the current GPUs, and DLSS3 lets us render intermediate frames between existing frames, and we're using AI. So in the optical flow engine that's on the GPU. So why is this useful in virtual production? Well, let's say you have a content or a contribution feed that's maybe only 30p or 25p, but you're doing virtual production at 50 or 60p, right? So now you can use this DLSS to generate the intermediate frames that you need to get to the frame rate of your production. Or you can also use it to go from HD to UHD using AI so that your contribution feed matches your production feed. Moving on. Yeah, so that's kind of just a really quick introduction to Ada and what we bring to InfinitySet and the lighting and all the amazing things that you do.
Yeah, this is very nice, Thomas. The thing is that I remember many points in time where we had a lot of development together.
Yeah.
So for example, when you started in NVIDIA with this SDI board,
Yeah.
that we were building together something for the industry. The industry
Yeah.
was asking us, we need an SDI direct with no latency coming from the GPU, and you provide that. So can you remember something about that?
They brought me to NVIDIA to do that from SGI, and yeah, I mean, at that time, it was all about how can we bring the video I/O closer to the GPU in order to get to 50 or 60 hertz, and the way we saw doing that is to connect the SDI board to the GPU directly to do that, and then have a private pathway between the GPU video memory and the SDI board to get video out, like without having to go through the system memory.
Yeah, another of the things that I remember is when we needed to get from the computer the two views, the stereoscopic view. It was a moment in time where everybody was talking about the stereoscopic displays, and
yeah.
NVIDIA had to get this off the shelf, and we were, I think, the first one to use this system with you in a booth, probably here at IBC or NVIDIA. Do you remember about that?
Yeah, I remember a little bit about that. Yeah, I mean, there was like, all of a sudden, like, stereo was super important, so we scrambled to figure out how we could deliver stereo to you. And it's not just stereo, but frame accurate, properly synced for broadcast stereo. So yeah, that was a challenge that we worked on together. I remember that very well.
I also remember, I don't know when, maybe 6 years ago, something like this in Vancouver, when you first announced this ray tracing thing, maybe around this time.
Yeah.
Also, this enormous capacity of the GPUs that drove you to a new level.
Yeah, I mean, we kind of got to the end of grow shading technology. So the next logical step was to move to ray tracing, and the silicon and the hardware technology finally got to a point where we could create these RT engines or RT cores on the GPU to do ray tracing. And now, like I said, with Ada generation, we finally get to, I mean, that was kind of like a teaser for you, like, oh, you can do ray tracing now, but you couldn't really do it at 60 hertz. So yeah, here's this great ray tracing feature, but how useful was it? But now with Ada, we get to 60 hertz, and you can use it in your virtual production every day.
Well, I think it was the beginning of a new era, because it was a big changer, so for everybody.
Yeah. It's like everyone, it's like, it's a whole different way of thinking about what you can present on a virtual stage. And
the quality,
it's
a big step in the quality of your sets.
Yeah, because you get the shadows, and when you have AR features in the set, the shadows cast onto them, and it really ups the quality of what you can present to the audience.
The last thing I want to talk about is AI. I think NVIDIA has been the driver for the AI in the world, but
Yeah.
what about AI in the real-time graphics? What are the things that you brought that we are using?
Yeah, so we think of AI in three different ways. We have like predictive AI, or the data AI, which is analyzing what viewers are seeing, and then we have feeding that into what you deliver to more personalize the experience. And then there's generative AI, which takes the content and makes new content. And then we have video AI, which is some of the SDKs and toolkits that we have to take video and do super resolution, or do super slow-mo, or do audio denoising, or audio cleanup, and all those features are things that you use in InfinitySet every day to like up the step of what you can deliver to the audience.
In fact, in InfinitySet we have implemented these technologies for DLSS, as you were commenting before, also for the pose estimation. We can get the talent pose and know the position in the space, and these are very helpful tools from the AI that you're providing.
And there's more great AI to come. I mean, you're starting to see it now with companies that can deliver you a background plate from a simple drawing or from a photo. They can deliver you an accurate background plate with all the levels extracted.
Do you think that the 3D is also coming?
Pardon?
So that 3D is also coming, like a generative 3D?
Yeah, that was kind of my next thing. Like today we can do neural radiance fields, and it's kind of an very active area of research, and they're not real time today, but like ray tracing, we're going to get to a point where you can take a bunch of camera views and you can generate the whole 3D scene in real time using AI and have a full like 3D virtual set. And then we also have Gaussian splats, which is another similar technique.
Yeah.
And it's only time before you'll be able to do that in real time in the GPU for virtual production.
That looks really amazing. Thank you, Thomas, for your help. And I think the relation between NVIDIA and Brainstorm is a wonderful thing.
Yeah, it's great. Thank you.